during the presentation. You guys can ask in the chat box. Also, we will provide one feedback form at the last. You will get certificate for after filling the feedback form. Now it's my pleasure to introduce the speaker, Mr. Sayantan Mondal, Senior Research Scholar at Department of Geography, Delhi School of Economics. Uh, Presently, he was one of the most first people from geography to integrate this AI with this disaster management, disaster risk reduction kind of things. So we are excited to hear their insights and explore how these advanced technologies are shaping in future of disaster risk reduction. With that, I now invite Mr. Sayantan Mondal to take over and lead us through today's session. Over to you, Sayantan.
So, am I audible?
Yes, you are audible.
So, first of all, good morning, everyone. I am Sayantan Mondal. I am basically from Kolkata. So, presently, I am doing my PhD at Delhi School of Economics, Department of Geography at University of Delhi. But before this, I was also a student like you all, and Onik is my junior actually. So, we share the same institutions. I've done my graduation from Presidency University, Kolkata from 2016 to 19 batch, and I was the second topper of that batch. Though that being second, being third, or being first doesn't matter at the higher level because it's all about at the present what you are doing. So I just want to share one thing first. That first of all, I want to thank Oni to approach me. Yes, we are working relentlessly on the AI, specifically on the geospatial analysis part. So before diving directly to the AI in the geospatial integration, first I will tell you a small journey regarding that why I tend too much towards the data-driven decision-making system rather than the conventional methods that are in geography. So before starting the integrations of AI in geospatial analysis for the disaster risk reduction or for the disaster management or for disaster prediction or for hazard prediction, I just first want to tell you something that whenever you people are here today, and I am expecting that you will be the next generation that will carry forward this geospatial part, especially from the geography. So those who are here, you all are serious candidates, you all are young, and you have a lot of energy to learn a lot of new things. So this is the most important thing I just want to tell you before starting this. Because there are a lot of myths that needs to be bursted first. See, majority people, those who are here, are either from the geography or geology or art science backgrounds. Majority. There might be few rare people from other different backgrounds, but majority are from this backgrounds. So coming from this background and especially diving into the GIS and remote sensing is itself takes a heavy toll. For example, it is not like a regular theoretical chapters or any theoretical things that you can memorize or you can learn the concepts and you can write in examination. This is a day-to-day, daily life execution process. Each and every day you have to touch down to this technical era. In this technical arena, you will have to solve the problem, you will have to solve the technical glitch, you will have to solve the errors, and then you will have to find out the daily solutions. So I am not going into the definitions or very basic part of the geospatial thing, that is the GIS and remote sensing, because if I started talking about that thing, then it will be another domain. But majority people, those who are here, they all, I can understand that more or less they all are acquainted with at least the minimum or basic knowledge of geospatial analysis or remote, or in very simple or layman's language, we call it remote sensing and GIS. So whenever you feel any doubt, you can ask the question also. I have no issue with that. Okay, so if you have an immediate doubt, you can ask at that point only, because otherwise you will forget about what problem you aroused or what question or what curiosity that came into your mind. So you can stop me anytime. You can raise your hand or you can ask directly questions. Okay, this is the first thing. And I will ask Onik and the team members that if there is any question in the chat, then please tell me because I'm not watching the chat now. Okay. So if there is any question, someone types in the chat, then please let me know. Okay. So we will go through very simple steps first. There is no bombardment in anything that is this thing is you need to know, this statistic, you need to know that statistic. Yes, we need to know, but it is not the immediate requirement. The first thing is that I just want to show you one map. Okay. And before starting, I am telling whatever thing that I will tell, these things are all from my experiences. 90% of the work that I will show you here are done by myself solely, and 10% I will show you that my colleagues have made from the same laboratory. Because we all take part in each other, we all help out each other, we all acknowledge each other in this work. Because without collaboration, this type of complex algorithms or this type of complex execution of this complex algorithms and getting a good output is very difficult, or at least at the beginning or at the stepping stone of this AI integrated geospatial analysis. So before starting with, this is a study map. This is a study area map. You can see this is actually my study area map. My entire work is on this study area. So you can see that GIS is important. Whether you from a geology department or geography department, nowadays geology, this remote sensing part is very much integrated in everyone's life. People from civil engineering department to glaciologist, environmentalist, environmental consultant to geographers, geologists, everyone is using AI. Sorry, everyone is using the geospatial analysis. So this first thing is that why this geospatial analysis is really important in various segments, because we call it GIS, which consists of geographical informatics system, but this is not limited to geographers. There are other departments, other fields, and other domains, those who are using this GIS in such a way the geographer can't even think. The main problem that I found among the geographer is the misconception of telling that I know the GIS, but GIS, knowing GIS is not equivalent to creating few maps. GIS is much more complex than that. It is like DSA of computer science background, that is data structures and algorithms. So we need to understand this thing here. Being a geographer from India or being a conservative geologist from India creating a map does not suggest that I am a GIS expert. You need to understand that. So we all know that to create a study area map, or those who have done study area map, they know the basic of the GIS because they have to make multi-layer plane, then they have to do some overlay analysis, and they have to introduce some of the hillside analysis. Like you can see that my Chamoni district here, there is a hillside analysis. I have done a hillside analysis over in ArcGIS Pro over the terrain, and I found out this map, and I developed this. So in this way, you can understand that how GIS can be used in our field. But the most important thing is that if everything is good with GIS, then why we are moving to cross-platforms algorithm? Like we are moving to Python, we are converting the entire data from this GIS into the Python, and then we are then calibrating. And nowadays people are using the ArcPy, that is Python integrated in the ArcGIS Pro. So they are integrating in that way also. So in this way, the question arises, till 2020, 2018, 2017, this type of things are not needed. But now these things are. Why? You need to understand that first. So before diving into AI, just because it is trendy, it sounds cool, first we have to understand this concept, that where this GIS is lacking, or where this analysis or the algorithms inside a conventional GIS software is lagging, or what are their disadvantages that leading people to move towards a cross-platform things like JavaScripts and Python interfaces to do the work. This is the first thing you need to understand. I just want to give you a small example. There are many papers, or there are many researchers in last 15 to 20 years have been done on 3 to 4 main concepts, like AHP, analytical hierarchical process, or MCDM, multi-criteria decision-making process, or there are overlay analysis, and then they are making raster calculations. I know that some of these terms might be technical. If you face any problem in understanding, you can ask me that if you are not getting what I am trying to tell, please don't take my lecture like a bouncer. Then you can't get through it. So you need to ask me if you are facing any problem. So suppose, for example, someone is telling you that I have few geospatial parameters, and on basis of that parameter, I want to build a school. So, for example, this is a typical example of a site suitability analysis. To have a school, I need a road nearby, I need a buildings nearby, I need few markets nearby, I need a transport mechanisms nearby, I need good weather nearby, and I need a good weather road nearby. So more than 10 to 15 parameters are there as a deciding factor for building or for selecting a site where if a school is made, then 3, 4, 5 towns or 3, 4, 5 villages can get proper access to it. So for that, a geospatial analysis is required. For this type of site suitability analysis, or for this type of, for example, flood mechanism or flood susceptibility modeling, what is happening is that people are using, or the researchers are using AHP. The question is, AHP is also giving a good map. Okay, these places are susceptible to flood. These places are susceptible to landslide. These places are susceptible to forest fire. So, probable area where this forest fire can occur, every map can give. Analytical hierarchical process can also give. MCDM techniques can also give. And plain overlay analysis can also give. The question is, everyone is giving a map. But in reality, the map they are showcasing, is that event occurring there actually or not? This is the biggest gap that we found using AHP, MCDM, or this TOPSIS method, or there are other overlay analysis. So nowadays people are not only looking for the interactive maps, they are looking for the precision map. So the precision of the results or the outcome of these maps are not always accurate. So to understand this, that why these maps are not accurate, we have to go deep into the technical things where these algorithms are lacking. For example, analytical hierarchical process. In an analytical hierarchical process, we have to assign some weight to each and every parameters in a rank wise. Now, how we are giving weight to these particular parameters, that depends on the subjective biasness and subjective expertise. Sorry to use the term subjective biasness, we call it a subjective expertise. Now, how will we quantify that this person is expertised or not? There comes a subjective biasness. So when there is a bias in the weighing or in the ranking of the parameters, the ultimate results will always be affected. So to bypass this entire thing of assigning weights in MCDM as well as in analytical hierarchical process, people are running towards a target-based machine learning and deep learning algorithms, which is typically comes under a broader domain known as artificial intelligence. This is where the AI enters. In my work also, when I was studying with my study areas and I was dealing with what type of work has been done, a lot of different types of work has been done, and yet an accurate landslide susceptibility zonation has not been created by any geographers of that time. There are few IITians that were doing really some good work, but they have also used some of the machine learning, but not an advanced version of deep learning algorithms. So here you have to understand that why I jumped from this conservative domain of analytical hierarchical process, machine learning and MCDM techniques to machine learning and artificial intelligence. Okay. So we all are aware with this type of parameters that have been shown in the map. See, there I have shown only few parameters. Hardly there are 10 parameters that in GIS softwares we can make, like curvature, aspect, distance from the road, geology, altitude, because these are the parameters that are needed to assign any of the work you want to do. For flood susceptibility, for drought susceptibility, for landslide susceptibility, and for any type of work. Even if you are doing or dealing with the conservative approaches like analytical hierarchical process or MCDM or any other TOPSIS methods also, you will have to make this. So in machine learning also, we have to make it. But the game begins because from here, The difference is that we are not integrating all these things together here. We are using statistics. We are using various parameter collinearity checks. And then we are working on the artificial intelligence part and how these things are made. I will guide you to the basic part, that an overall overview that how these things are made, not that much in detail because I need to show you a lot of other fields where AI has been there, and I'm assure you the last one, which is the most special contribution of mine work in this field, which is not done in India before. This type of work, the last work that I will show you, that is something that has been continuously done by Chinese and some European agencies in some of the good journals like Remote Sensing of Environment and ISPRS Journal of Photogrammetry and Remote Sensing. But I have done it and I have submitted one paper. It is under review also in a very established journal like ISPRS Journal of Photogrammetry and Remote Sensing. So if you have some patience, have some patience and see what things that I'm going to tell you. And one thing I assure you, the things that I will going to tell you, these are things are not shown before in the geography domain. So stick to your seat, try to understand, and if you feel anything that I'm not getting it, please ask me the question. I'm happy to tell you whatever problem you are facing. Okay. So before arriving to the artificial intelligence and machine learning, I just want to show you a basic diagram. So this type of diagrams are known as bibliometric analysis. This is basically a core literature review that has been visualized in the form of a graphical era or in a graphical abstract, where you can see that the recent trends of machine learning in geospatial analysis that have started from 2017 to 2023, you will find that from 2020 onwards, there is a huge bloom in this type of work. That means in last 5 years, you will find a lot of work has been shifting to machine learning in geospatial analysis. Similarly, if I take a trend from 2001, you will see after 2018, you can see there is a big bloom. So it is not that we are the only one who are using this type of technologies, but there are in entire world there are a lot of other departments, lot of other schools like School of Natural Sciences, School of Art Sciences, School of Civil Engineering. They are all using this type of things from 2018 till date. So it's the 7 years of game. So it is not that much old, but not that much new. And this is the perfect time for each and everyone in the geospatial to little bit crawl towards this artificial intelligence part so that you can cope up with time as well as technology, and you can surely get something out of very beneficial something out of it. Because practically speaking, if you are sticking to the core geography, I am not making a distinguish between a physical and human geography, because nowadays human geography people are also using quantitative techniques and very good artificial intelligences in human geography also. So science is not fixed to only physical geography, because in India, the geographers made a huge distinctions among themselves, like those are human geographers, those are physical geographers. Physical geographers are much more science based, and human geographers are not that much science based. No, this is completely wrong. Because nowadays in human geography, you have also the way you have to understand in this way that physical geography is not more geography anymore. It is consisting of geology, soft computation, computer science, because people those who are doing a hands-on on GIS, they know a very good of computer because they have to install the software. Either they are not the original registered versions also, so they also have to do with lot of critical technological things. So no one is fixed with basic of the geography, like we will only study through books, mugging up the books and giving examination. This is not being there nowadays. And similarly for human geographers also, human geography is not linked to only behavioralism and geography of thoughts and some of the theoretical aspect or some of the inductive studies, especially going to survey and taking the data out. But nowadays, these inductive studies are also including one of the prominent part of the AI. Because I just want to give you one example. Though my entire work is a bit of technology oriented, a bit of AI oriented, but in a broader domain, you will find that ultimately we are giving a decisions to the society. So whatever you divide the geography into human geography, but into physical geography, but we have to assess the physical geography for the human beings only. So whatever work you do, you have to do for the societal goodness. So when you are talking about a societal goodness, that is also part of a human geography. So I just want to give you one example by not wasting much more time, that how we have used this artificial intelligence in a human geography work. Basically, for the last 3 months during the 2024, I have visited 7 districts in West Bengal. From it is from Birbhum district to Midnapur district. I have crossed total 7 districts, and I have surveyed over 400 people using a very scientific way of developing a Kobo toolbox. Kobo toolbox is a very good interface that any human geographers can also use, because you don't have to write anything. You just take the data digitally, and it will automatically get stored into a server or a cloud server. But the technical thing is that you have to make that question paper. It is not simple as a Google Docs, but a bit complex, but not impossible. If I can make, you people can also make. So in this way, after taking this data of 400 people's data, then we are analyzing this data with the artificial intelligence. We are creating different types of charts, we are creating different types of indexes, and we are also predicted some farm to non-farm transformation using this geospatial, using this artificial intelligence. So you have to understand this point, that this AI is not limited to only a physical geographer. This is also to the human geographers, and there are a lot of consultancies in the entire world, those who are recruiting human geographers in the policy making of disaster risk reduction. That is the topic of today. So when I am talking to the topic or talking to something about the human geographer, I am also sticking to my topic. That is, today's topic is the disaster mitigations and disaster risk reduction using artificial intelligence. So there are post-disaster surveys are doing on the psychological impact of the people. For example, some post-disaster work has been very beautifully done on the Idukki Dam clash, the Idukki Dam that has been destroyed in 2018. And same has been done in the Rishiganga region in 2021, 7th April 2021. There was an huge devastating slope failure and avalanche failure that lead to a flash flood in the Joshimath region. So post-disaster scenarios are much more traumatic. So using AI to do a sentiment analysis, before sentiment analysis are done using the expertise of the sociologist experts. Nowadays, human geographers can also do a sentiment analysis using the artificial intelligence also. So those who were thinking that this AI/ML is only for the physical geographers, no, geospatial researchers are also there for the human geographers also. So there is no distinction. If you are going to higher studies, there is no distinction between a physical geographer as well as a human geographer, because all are interdisciplinary, all are interconnected to each other, and these are all working together in a cross-collaborative platforms. So I think you are all getting my points, and if you are facing any problem, I am repeating you that please tell me if you are facing any problem. So after having these deep discussions on the trends and applications of AI/ML in this geospatial research, we will move to a next step, because now it might sound boring because I'm talking a lot of lecture instead of showing you what actually going on in this field. Okay. So suppose now start with the basic statistics. I was going to tell you some of the important concepts that no one tells. This is the main thing that you can see in this. There are parameters. In this slide, you can see the parameters. And in this slide, the parameter name are given like aspect, curvature, elevation, geomorphology, relative relief, slope. You can see I have divided these parameters into few classes. For example, the classes are like geomorphological, geological, environmental, and anthropogenic activities. To work with the machine learning algorithm, first thing is that we have to be statistically correct that whether each of these parameters are collinear with each other or not. That means, for example, if aspect is replicating the exact way the curvature is doing, then the aspect and curvature both are having a same property. So if these both are having a same properties, whenever we will run a machine learning algorithm, there will be a biasness towards this aspect and curvature. So in this way, we need to find that whether any of these parameters are either related to each other or not, or if there are any significant relationship with each other or not. For example, many people of you have done the work on regression. You have got the value of an R square. If aspect and curvature started to work exactly together, like they are like twins or they are like collinear to each other, then the aspect and curvatures R square will be almost 1. So that here comes our biggest problem. The thing is that to do with this type of work, we need to understand the first thing, that is the these triggering factors or these parameters which are present here, whether they are collinear or not. To find this collinearity, we do a basic statistics known as tolerance and VIF. VIF is known as the variance information factor. And there is a given range that a VIF less than 10 and a tolerance value greater than 0.1 are very good for the adjustment of the parameters. So now the question is, if you find that the elevation or geomorphology or relative relief, this type of functions having VIF more than 10, then that means in elevation or geomorphology or relative relief, you have to take any one. It acts in the same way, the way principal component analysis works. Basically, we are reducing the dimensionality of the entire parameter system. So this will help in providing much more accurate prediction, number one. And number two, the most important thing is that the biasness or the influence of one parameter over the other will be reduced. So everything is done here to reduce the biasness and maintain the precision of the work. So moving to the next.
Mondal, I think
Yes.
Shautamita has one question. He
Okay.
raised her hand. Shautamita, you can ask the question.
Yes, hello.
Hello.
Yes, sir. So actually, it's kind of a basic question because the topic is AI on disaster management, and now AI, including other aspects like machine learning, have become more common. That people of different fields, like just like you mentioned, the civil engineers are coming. Once they're doing AutoCAD, they're also coming in the GIS field. So, and what can I also ask that what is the human part and the machine part, like what human can do and how not we can be replaced by the machines and AI. So how we can survive in the market also.
Okay. I got to understand that. So the first thing that I want to tell here. Now, this is a very interesting question actually. That how will we not be replaced by the AI? See, AI, the artificial intelligence is not creative. They can do the automation, they can generate you the code, they can generate you the results. But what you actually want to do in this work depends entirely on you. I am giving you one example. For example, you are working on a flood hydrodynamics using artificial intelligence. So you will be measuring the flood. For example, you got a 30 years, that is one climatic year, IMD data. And you have given the AI that, okay, AI will help to mitigate this 30 years data, and the AI will provide the final output in a form of hydrodynamic model. But if you are creative, but if you want your result much more focused on the floods and its mitigation and its real life scenario, you have to think beyond this 30 years of IMD data. Because if you see in this 30 years of IMD data, 70% data you will find rainfall less than 3 millimeter, that symbolizes dry days. So a 30-year of data, if you are putting directly into a machine learning model or in an AI-based system, what the AI will think that, okay, so this data that I have got 70% of dry days, 10 to 15% of transition days, 5 to 6% of wet days, and very 1 to 2% of extreme days. Okay. So at that point of time, the way he will, or the way the model will train this AI, there will be a biasness towards dry days. Here comes the human intervention. Because if you want to make a hydrodynamic model on the basis of that I want to make a policy such a resilient that if next 100 years peak flood also arrive in my study area, the buildings will be resilient and there will be no flood in my area. Then in that time, you have to exclude that 70% of the data. You have to first observe how many data are there in a very extreme flood for last 30 years. And you have to also find that what is the peak rainfall that has been occurred in that particular time. And then you have to find the rainfall runoff of that particular pixel or that particular area of that particular time so that you can get an extreme value. Now, based on that extreme value, then you will also have to use your brain to evaluate the monsoonal values. So see, there are a lot of little um, subcontents that are present here that need to be keep in mind while training the data. These things can't be done using directly putting everything in AI. AI can't replace this thing because human creativity is there. That's why AI has been present, and at present AI has been here. But the moment if you think that AI will take our jobs or AI will take our career, then you have to switch your career in creative field because they can AI can take the career. Okay, if you are a content writer, AI can easily replace you. You can, if you are a developer, you can blindly write a beautiful code that can be replaced by the AI. But thing is that your critical thinking, your critical analysis, these things are more important. Okay, so while doing or executing any project, there are a lot of things beside AI. That is the whatever I do using AI or by not using AI, whether the result will give me a real life scenario or not. This is the first biggest question that one asks oneself before diving into technological derivatives. So in this case, your question is justified that AI can replace or not, or there is another important question about the identity crisis of the geographers because civil engineers are working on the same way, other sectors are also working the same way, but the geospatial knowledge that a geographer has, these things cannot be inculcated by few lines of code or few specific work related to geology or civil engineering because there are a lot more geospatial things that a geographer needs to maintain. For example, I am just giving a small example. Okay, being a geographer, we are well aware of our directions like east, west, north, south. So if you are working with a flood susceptibility modeling in the area of Himalayas and also in the areas of Mumbai, the problem with the AI engineers, the problem with the civil engineers and geologists will that they will also do the all the statistical parameters and everything. But what difference that a geographer will make here? Because geographers will also know the same technical things that they are doing for flood susceptibility, but there will be some of the parameters. For example, aspect. What do we mean by an aspect? You can see there is an aspect map here. You can see the second map is an aspect map. So what is an aspect map? It is the basically a map that shows that in from which direction the sunlight is actually falling on the earth surfaces. So in this aspect map, it is showing the faces and the directions of the topography. So for mountains in Himalayas, we all know that rainfall occurs much more from the southern slopes. So the aspect in the southern slopes will have more rainfall. So the area of the southern slopes can face more landslide as well as can face more debris related floods. But similarly, if you see the Western Ghats in Mumbai, the flood occurs from the western side. So the aspect of the western sides are different. So assigning a greater values to the aspect on the western sides of Mumbai and the southern sides of Himalayas is the only thing that geographers can make a difference. Here you will make the difference. So you have to critically think and apply your subject knowledge to this type of work because AI knows nothing more than a data. Whatever enriched data you provide to the AI, the results will be far better, and you have to scientifically justify it. So now let's dive into the what type of work that can be done with the AI ML. And I think Shoptomita, you got your answer. And if you are not certain, you can again
Yes,
ask me if there is anything else you want to know on. Okay. Okay, now coming to some of the neural network architecture. Okay, don't get confused or don't get scared by watching these architectures. These are some of the basic architectures that you can make in any of the neural network architecture website. Basically, I am showing you that how this actual architecture works. Basically, we all know the MLPNN. It is a multi-layer perceptual neural network. What happens is there, you can see there are 18 layers. Okay, these 18 layers are basically the parameters that you will be using. I have made the 18 parameters, so I have used 18 input layers. Each parameters will come as an input, and there will be some hidden layers. in these hidden layers, what will happen? There will be a mechanism, a theoretical knowledge is required to understand the basic. In a neural network, there is a basic foundations of feed forward network and backward propagation network. Using feed forward and backward propagation to the target, we have to provide a target also. Whatever historical data are there, that historical data will be the target. So we are having, for example, 5 plus x is equal to 7. You have the 5. 5 is your parameter and 7 is your target. Okay. So you have to find the value of x. So how will you find the value of x? They will run this 5 through x and they will get a result to 7, and they will find that 7 minus 5 is equal to 2. Then they will again come backward and then they will again assign a value of 2. So this is a feed forward as well as backward mechanism. I am giving a simple example with one structure value data, but when there are multiple structure of value data or multiple parameters, each of these parameters will stick to some of the loss values, and assigning that loss values, they will give a final functional output. So we know the target and we know the input, we will get a functional predicted weight. So this predicted weight is far better, or this predicted model is far better than assigning an arbitrary weight that has been done by analytical hierarchical process or MCDM technique, which can lead to subjective biasness. This thing replaces the entire game of these conservative models in respect to geospatial analysis. I hope you got this one. So similarly, these XGBoosts also give in that way. They have a different types of tree, like classification. For example, if you will have worked with land use land cover changes, majority people of you have done land use land cover changes. You will be astonished to understand that in the land use land cover changes that you have done in either ArcGIS or ADAS Imagine software, you will find there was one classifier that I've used for a supervised learning mechanism, that is known as maximum likelihood classifier. This maximum likelihood classifier is also an artificial intelligence algorithm. Though it is not that much complex, it is quite simple. By combining 3 to 4 different types of maximum likelihood classifier, we make one tree classifier. And here, this one tree that I am indicating using a mouse, this one tree consists of 3 to 4 maximum likelihood classifier, and now 3 trees together forms an XGBoost. So basically, I'm showing you how these architecture actually mean in real life for the geographers, because as a geographer, we are not acquainted to the computer science and engineering part, how these algorithms are made or what are the technicalities or theories behind this algorithm. But basically, I am showing you some structures so that you can get an overview of this and you can move forward with exploring these things in your later stage. So this is one of the landslide susceptibility maps that you can find. The red places are the areas of Chamoli district. You will find that red places are those places where landslide can be a very big threat, because these are the places where the susceptibility of landslides is very high, or there's a very high chance that these susceptibilities will be done. So you can see that the susceptibility is, you can see there is some carved path. You can see there is a carved path. These all carved paths are there because it is because of the roads have been gone through this area. So in my algorithm, I have defined that in which way my susceptibility map will be made. For example, I am making susceptibility map and there is no human being, then there is no threat to human being, and then that will never be considered as an hazard map. But the place where these civilizations are there, the place where build-ups are there, if we are finding or analyze or research on the areas on that particular places where there are so much people thriving or so much people living, a landslide can be a fatal disaster to that area. So in artificial intelligence, you have to understand this thing, that your work should be a problem specific, not a grammar specific machine learning algorithms. Machine learning algorithms works through some grammar, but here, based on the situation, you have to modify that machine learning algorithms so that you can find a valuable output that will give a realistic scenario. Then when we do a machine learning algorithm, for example, if you have done a AULC math, you will find that you have done a kappa coefficient, that is the accuracy assessment. For a machine learning model, the accuracy assessments are AUC ROC card, that is area under receiver's operating card. Or there are some of the confusion metrics are also present, which consist of an F1 score That is basically a ratio of a precision and recall values that we can get from a confusion matrix. So what does a confusion matrix shows? According to statistics, a confusion matrix shows some of the false positive, false negative, and true positive, true negative natures of the work. I know that you people are not acquainted with this much of advanced statistics. I'm just telling you to get acquainted with this terminologies so that you can understand that what you need to learn in future. Okay, so these are the areas I want to showcase. That this is one of my research paper, and these are the areas that are the red areas that I have predicted that where landslide might occur, and there are some historical landslide has also been present. You can see all these areas in red. I have been marked here. These some of these images, like these images, this image are taken by me. I have visited these places and taken the image personally using the ground control points and the GCP based marking systems, and I have shown you that how this prediction is very much accurate to this area. And next, in my next diagram, this is the this was a game changer for my work, because in 2023 I visited this place and I have predicted this map using one of the most sophisticated AI mechanisms, and you will find that the red areas, the places where there are very high landslide, is very limited. But see, among this limitation in this area, I have these file photographs have been taken in 2023, and this area I have taken this photograph by myself. And this is the 2024 photograph where there have been landslide. This place presented in my prediction in 2023. You can see the date also, and this is the same area. The landslide has been occurred in 2024. This is basically a Patal Ganga landslide that has been occurred here. So you can see how this artificial intelligence based susceptibility model has given a real life prediction that has predicted the entire thing, luckily within 1 year or 2 years of my entire work. I started this work in 2022, I completed this work in 2023 and submitted this work in the late 2023 end, but the results, before getting published, this landslide occurred in my study area. So this shows that the prediction is quite accurate. So you can see how AI is enhancing the accuracy in terms of prediction. There can be no greater example, and I'm proud to share this image that yes, we are doing something different. We are trying to do something different. We are trying to excel in something. So I want this encouragement in you people, that you people also, yeah, you are young, you are young minds. Okay, so you can do something better than us also. You can innovate these things, because research is like researching again. You are searching and you are researching research. I have done till this. You people can do something better tomorrow also. Okay, so now coming to the next part. Okay, we have talked a lot about the models and algorithms. Now let's come to some of the basic things, that is the computer vision. Okay, so in computer vision, in a lot of scientific movies or sci-fi movies, you have seen that how people are tracking the, especially spy movies like Jason Bourne or the Ethan Hunt movies like Mission Impossible. You have seen that how they use computers to identify a single person, that there is a crowd moving out and they are detecting the photo detection algorithms are there also. So this is one type of very basic photo detection algorithm known as segment anything model. This model has been developed in 2023 by the name of the professor I really forgot now. He is from Tennessee University, Quisen Hung. His name is Quisen Hung, and what he has done is that we used to digitize the buildings manually before. We people digitize for, if you want an accurate localized in your, if you are working on an area which is a very local area and you are working on digitizing each and every buildings, it will take a lot of time. This SAM model or segment anything model that I run in a Google Colab using a basic Python algorithm, what they have done is that they have detected each and every buildings in the image. See, this is an raw image you can find. This is a leaflet image, or you can say Google image in same way. How they have segmented using artificial intelligence. I have not done a single digitization, and how they have masked the tip. After masking the tip, I have converted this tip into a shapefile and I got the buildings extracted in a matter of no time. I have done the six times batch processing, and sometimes it takes requires a lot of time to generate, but it the laborious work, the time taken and the accuracy is far better in this type of maps. In spite, if you are working on a very high area where there are huge amount of buildings and you want to digitize each and every one. For example, those who will be working in future in urban planning or in urban morphometry, this SAM model can help you a lot. So I can show you. These are all the buildings that I have extracted using a SAM model, and I have not done a single digitization. And after that, I have made a 3D modeling of this building using the basic ArcGIS Pro. And you can see these are the ArcGIS Pro, these are the fault lines, and how I can show that. See, this is the blend of an artificial intelligence. You are AI to segregate the buildings, and then you are showing this in a geospatial manner. So that means you are not shifting entirely from geography or GIS remote sensing to artificial intelligence, but you are using artificial intelligence to showcase your geospatial visualization in a far better way. You can see how this 3D map has been created, how the demarcation has been made. This thing has not been possible if I have to do everything manually. Okay. So now this is a recent paper in 2025, 20th March, this paper has been received, and on 2nd June, this month, this paper has been accepted. This has been done by my colleague, Mr. Gopal Chaudhary. He has done some good work, and we both have done some of the beautiful work in this AI/ML integrations. He has done a lot of rigorous work on creating the data set. The thing is that I want to show you something. This is the rich data set that he has made. He asked me that, Sayantan, I need some algorithm. And I told him to get some algorithm, but you have to make a very good enriched data set. This data set should be much better than an AHP based data set. So he made a very beautiful data set for 6 to 7 months. So creating a data set is very important. And if you are at the beginning of your stage in artificial intelligence, it will take 5 to 6 months to understand how to create a good data set and how this data set can give a good result. So he has done some beautiful work with good data set. He has made some tremendous visualization in this work. You can see all these things that he has made. These have been done by AI only. There was one software. That software has helped to make this flowchart also. So we have used this AI to build this thing, and he has some innovative thing. I have given him some of the ideas that you can do in that way. And after getting that idea, he has worked with this. And you can see that this is the algorithm that he has been used. These are the types of diagrams I have given the same diagram that I've shown you before the MLPNN, and this is a decision deep sensible learning, quite different from an XGBoost. And there are some meta regression. I'm not going in deep into this because you will not be able to understand this type of things right now. So you can see that in agricultural sector, you can find that this is an agricultural sector where the artificial intelligence have been done. You can see the topic name. It is basically an agricultural distress in the eastern plateaus of West Bengal RAR region. This is the first kind of work that has been done using AI in this field. No work has been done in this agricultural district using artificial intelligence and this type of algorithms before in RAR region. So see how these data have been accumulated, how these data have been compressed and overlapped with each other, how data are extracted, and how the final maps and the accuracy assessments have been done. And you can see I have taught you before that about the tolerance, and he has also made the tolerance, and no value has exceeded 10. So all these values are within the BIF 10. Okay, so this shows that how each and every precautionary steps are taken before directly running into a machine learning algorithm. This is the difference between AI and a human thinking. Okay, so these are some of the diagrams that nowadays people are wanting or demanding for paper publication. And these are Shapley diagram, and this is a confusion matrix where you can see that you need to understand these concepts first, because these diagrams are required after as a validation process of your results and execution to get published in a very good journal like a Q1 journals. Okay, so this is his entire work, that how he has done and how he has visited each and every places where there is a mark, and each and every places he has validated going on the ground. So a ground validation in AI work is very important. So you are doing an artificial intelligence work and there is no ground validation, then people will not take you seriously. This is the important thing. You have to show them that yes, this work gives a good result. Without ground validation, you can't do anything. So as a geographer, this ground validation is their core part. They can understand this better than a civil engineer and a geologist. Yeah. But geologists also do a very good rigorous ground verifications because they need to go with the hardcore geology sections. But in a broader scale, as a geographer, their surveying techniques and their validation techniques are different from a geologist. Okay, so what other work that we could do that are using the artificial intelligence, that is before directly running to an AI/ML algorithm, Shoptomita asks that what else we could do that AI can't replace us. This is the random sampling techniques that I have used. That how we have used a k-means unsupervised clustering techniques for doing some work. Because, for example, randomness is not easy to tell anything is random. Because few days back also there are one research scholar has developed some new algorithm for deriving any randomness of a data. So randomness is a very big statistical part, and we need to understand that how we can randomize. This is an area of Mumbai, and I was taking few samples. So how to take a sample from all of these spaces, maintaining the spatial equality in a geospatial world. So I have done a k-means clustering so that I can take each and every cluster and each and every value from each and every corner and each and every spatial locations of this Mumbai map. So if there has been not a geographer, they could have taken any random samples, but that might lead to over clustering of a data from a single area. So concentration of data would have been very high. So being a geographer, space is a very important place that plays a very important role in assigning that from where you are taking the training data or testing data. So as a geographer, this is the superiority that no one can snatch from you. Or not as a geographer, as a researcher. I will not use the term geographer, and I will not distinguish people from geography, geology, hydrology, anything, because when you will be doing PhD or higher research, you all have to collaborate. All have their own advantages, all have their own disadvantages. So it's a collaboration. So I'm sorry to use the term geographers many more times. I will not use that. But as a researcher, you have to understand this spatial locations and how from each and every spatial location if data are extracted, the data diversity, the heterogeneity of data becomes very high. So it will reduce the data homogeneity and reduce the cluster of the data. Okay. So this is one of the posts that is still now circulating in LinkedIn in a very popular way nowadays, because also reacting nowadays in this paper. This is basically a flood susceptibility modeling that I have done that using this random forest algorithm. This is the same way you can see that whatever BIF and tolerance we have made, this is the graphical representation, or we call it a collinearity matrix is shown here. Okay, so these metrics are important. Then there are different other things like variance information factors I have to tell you before. This is the factor importance. Like in machine learning algorithm, you have to also understand that which parameter is being used maximum in maximum areas. Like for a flood, elevation plays a very important role, because so the value of elevation in parameter importance or variance importance is will be very high. So you have to understand this which parameter is playing very important role, which parameter is redundant. Then you have to remove that parameter, and again you have to run these algorithms. So these are the areas where human beings can surpass any AI automation techniques. Then we are moving to some of the things that whenever you have worked with the attribute tables or GIS data, I have seen you people have facing a lot of -999 error. That is the spatial error or not a number. To solve that error, you can see that all the peripheries, this is known as the edge areas, all the peripheries, there are a lot of errors you can find. These are all the true data, and there are some of the false data. So this you have to remove this false data and you have to clean this data. To clean this data, I have created one software named as -999 GIS data cleaning software. It is a very simple to use software. You can go to my GitHub or go to my LinkedIn to find this one. Okay, so you can also develop this type of small software using artificial intelligence so that you can solve a day-to-day GIS problem, because there is no toolbox in the entire ArcGIS or QGIS to solve these -999 issues. You have to either cut it or you have to distort some of the areas. So here I have solved that using this software. You can see you can get some of these true areas that points that not have been visited before, and then there is a forward and you can do a final check that no error is there. So I can show you one step also. You can take the data, you can take a CSV data also, shapefile directly. You can also directly put the shapefile here. This is a very important thing, because except GIS software, no software supports shapefiles properly. So this software can also support the shapefile, and you can see that there are so much 999 errors in like distance from the drainage, then flow accumulation, then final rain. And later when we click on the clean data, we got a very clean data, and you can see there is no value present here with this type of error, and you can export this clean file into a required directory. So in this way, I have also made some of the softwares to solve this issue. So basically, the point is that being a researcher, it is not about doing a bulk publication like 80 publications in 2-3 years, 90 publications, but you have to do some of the novel work, and you have to do some to stand out from the crowd. You have to do some problem solving orientation. Like, I made this software to solve the problem of the basic people. I will not get this published, or I will not get any extra marks for this. But this is a researcher satisfaction that if you do this type of things, it makes a very good impressions in interviews whenever you will go for doing some higher research or in in your professions also. So you need to do this type of things also. Okay, so how is AI helpful for geospatial data? In another way, we can download a various type of spatial data that has been not been possible without proper Python engagement and working with this data. This is an ERA 5 hourly data system for the global data. People are working on a large study area. You can use this type of data where you can see a time series analysis. I have made a beautiful rainfall graph. All these are made in Python. You can do all these things in Python. You can show this visualization that in which particular point this area where on which I have done this calculation. So this type of things you can do using geospatial analysis by, because extracting data is also a very important art. You need to understand this. So yeah, if you want to do a very good geospatial analysis, you need a very good data, a very good reputed global data, and extraction of reputed global data is not always feasible within the boundaries of geospatial softwares like ArcGIS and QGIS. You need to have a Python to work and understand and visualize this type of works. So this is another work that is a landscape accessibility modeling that I have made with some of the good charts. You can also see AI can make this, Python can also make this some beautiful charts. This is one of the pair plot chart, and this is a multi-collinearity analysis, which are very rarely you can find in a very good way. You can rarely find in some of the GIS softwares like ArcGIS or QGIS or any other ADAS or any software. And you can see you can create this type of maps also. Though these maps have been created in the ArcGIS, but the data that has been infilled in these maps, they have been made in the Python only. Okay, so this is another work. This is, you can understand this Sundarban area, and this is the work done by Mr. Arun Boydo, who is another colleague of my same lab. We are shared in the same geocomputation lab, who has used a deep learning algorithm to understand the tourism hotspot. So you can, those who are working on the tourism sectors in the geography, you people can also work with these geospatial analysis, that how deep learning and machine learning can leading to tourism hotspots, donations and predictions. For example, I am giving you a very good example, and if you want to apply your idea, you can apply to it. That last year I have visited. It has not been a 5 to 6 months. I have visited the Belpahari region of that is the Jhargram district, a very good district, and some of the new homestays have been made. So a lot of people in Belpahari region are trying to make a earning using the tourism sectors. So if you can assess this tourism, or you can identify these site suitability using site suitability analysis from the tourism hotspot, you can go visit that place, you can buy or lease some of the land, and you can create your own homestays, and you can create your own tourism activities. So in this way, see how GIS can also help in tourism sector also. I have worked with some of the tourism experts on that particular areas, and we've also talked that we will also introduce some of the tourism hotspot donation mapping using this artificial intelligence. So see how you can use your brain, and in this tourism sector also, how in tourism sector you can use geospatial analysis along with the artificial intelligence. You can see that these are the regions in Sundarban where some of the places you can have some of the, these are tourism hotspot, and if you find some of the places that we have a good potential of in tourism, you can help the NGOs, you can help the local people there to have to earn their living. So in this way, you can also help the society also. So see how this artificial intelligence can be used in this part. Okay, now coming to the one of the most important sections that I have worked, that is I have created a DEM, that is digital elevation model. You will find that the most accurate digital elevation models in India you can find in free data, that is allospulsar DEM of 12.5 meter resolution. Using artificial intelligence and advanced generative adversarial networks, I have created some of the advanced super resolution DEM, first filling the voids and then making a super resolution DEM out of it. So you can tell one thing very easily, that to fill the void, there is one option in ArcGIS known as fill DEM. So if you are using the fill DEM, you can easily fill the void, but that DEM is actually not filled if you use some of the high quality data like high mountain Asia data. These are the NASA data. You can't simply do with the field data. So you can see how I have tried some of this. This is an architecture theoretical tabular architecture in tabular format that I have made. So in this tabular format, I just want to showcase you that how these edges are different. This edge is different. These edges are different. We have to first match the edges to find the errors, and then we have to work on the super resolution DAMs. In India, no one works with this type of DAMs, but in China and Europe, they are working very good. So if you can tap into this domain, you can have a very good future in this remote sensing part. So you can see these are the voids of the dam. This is the final dam where the void have been reduced. You can see the original void, and this is the final dam how I have filled the void, and this is the area that have been filled. So filling this dam, you can see also there are some of the spots which has not been filled properly also, but this is the highest accurate dam we can find generate. We can fill the void and we can get it. So in this way, I can tell you that using advanced geospatial analysis and artificial intelligence also, you can make this type of void free dam, and that you can use in for your later work like flood susceptibility, debris flow modeling, or any of the high resolution and localized dam work. So you can see in this dam how I have used a satellite image. This is the normal dam. This is a void dam basically. This is the normalized large dam, and this is the satellite imagery. How I have introduced this satellite imagery, the light sentinel data, along with the dam, and fuse this image. This is known as the computer vision's image fusion technology, and I have made a final output. You can see how I have enhanced this normal sentinel-2 image with the some enhancement techniques, and I have enhanced this data. And with enhancement of this data, you can see that how I have made this void. There are some of the void present in this data, and in the sentinel patch also, I have cleaned this void. You can see how there are so much void. I have used sentinel data and I have cleaned this file. Now you can tell, is sentinel data really working on this dam void field? I can tell you yes. You can see that this is the sentinel data, this is the dam, and how the target dam has been created from these void dams, so that I can show you that how sentinel images is also playing. So this is a technology of image fusion where dam is a very different unit, sentinel data is a very different unit, but still normalizing these two data and then fusioning of these two data can give you a very good result in the void filling. So after filling the void, what I have done, I have created a super resolution dam structure. You can see the main difference here. This is a low resolution dam of a 12.5 meter allows pulsar, and you can see if we zoom this area, this is the dam that they provide, but this is the dam that I have made from this dam using this GAN techniques or generative adversarial network technique. You can see how detailed and how fine this dam is. So the entire dam that I have shown here is in a 3D format. Here you can see this dam is void field. This dam is a very high resolution, 8-meter resolution dam that you can never find in such a condition in entire India. So this is the things that you can do and work with these artificial intelligences. So I have shown you 5 to 6 very different and very unique field where you can tap into and you can find your research and you can do your research. And I can definitely guarantee you, if you work hard relentlessly in these things, then it will give you a very good output, and you can dominate this geospatial AI field, and there will be no fear of losing jobs to any other field apart from the artificial intelligence, that the civil engineers are entering our job in the geospatial analysis. We then we have to start the anxiety attacks and our identity. There is an identity crisis also. So don't get into these things. Study hard, work on this type of thing. These are some of the futuristic projects I have done also. I've worked done also on this, and I've submitted this paper in a very beautiful journal, like ISPRS Journal of Photogrammetry and Remote Sensing. It is the second best journal in the entire world, and this paper is under review there also. So okay, so this is the another thing, that this is a journal known as Scientific Reports. This is from the Nature's portfolio. This journal is a part of a Nature portfolio, and recently one of my paper has been accepted where I have worked on the novelty of the deep learning in the landslide sections, especially on the segment anything model, then landslide detections and some of the landslide susceptibility. So see, I am working on this, and I'm also getting some good fruitful results. It's like my paper is not getting published, that is not. The papers are in some of the very beautiful journals. You can see the scientific report with the Q1 journal with an impact factor of 3.8 now, I think. present Clavier's infrastructure has been provided, but it is a part of a Nature's portfolio. So publishing one paper in a Nature's journal in one of the very early stages is really challenging. It takes a lot of time and it takes a lot of effort, and it takes a lot of encouragement as well as a lot of perseverance to work on it. So if you want to connect to me, this is the LinkedIn barcode. You can scan this barcode and connect to me. This is my LinkedIn profile. Also, if you have some good ideas, we can collaborate. If I have time, I can also provide you some enhanced ideas. Also, if you really want to work with me or not, because I am always open to collaborations. I have also worked with two different fields. I was also working in some groundwater potential that I have not shown here because it is already more than 1 hour. I am giving lectures, and now you will might feel bored now at present because I'm talking non-stop for 1 hour. So this is my LinkedIn profile. You can visit. You can ask me anything. I'm very much active in LinkedIn. You can mail me. I'm active in email also. So let's make together a better place, a better geospatial world, so that we can work together, collaborate together. Because in this field there is no competition. There is only one thing that can succeed you. That is collaboration. Until unless there are collaborations, you can't succeed in any of the field. So thank you once again, and thank you SAIARD as well as ONE to give me a beautiful opportunity to talk with the young professionals, because when we work, we are completely out of students, completely out of the domains of the young researchers, that what they want to do, they might get lost in this field, but I'm always there to motivate. We are all there to motivate rather. And thank you everyone to giving me this platform and to give you a beautiful lecture on what type of work you can do. Thank you.
Many thanks to our speaker, Mr. Sayantan Mondal, for this outstanding presentation and sharing the valuable his expertise and real-world perspectives. We hope you found the presentation and discussion both thought-provoking and practically valuable. So in the chat box, you can see a link. You can fill the link, and you will be certified for this session. For the certification, it's a must thing. So do. Okay, Onkon has asked a question.
Okay.
He asked that as an undergraduate student, how can we enhance our skills in AI and machine learning and integrate in our research?
Okay, so whoever have the question, you can ask me now only. Okay, so thing is that Onkon, the thing is that you are an undergraduate student. I will first tell you, see, AI is not any subject. It is a tool that will help you to do your work. So there is no basic grammar of learning AI. You can learn AI in Canva also. You can learn AI for video editing also. You can learn AI for anything. Thing is that in whatever domain you are going, try to understand that in that domain how you can use AI. For example, today as we are sticking to the disaster risk reductions and everything, so in this type of domains also, if you want to work with geospatial analysis of GIS, first you have to be very much technically expertise with GIS. You have to understand everything, and after understanding everything, you have to move towards the artificial intelligence, that how we can include or inculcate this artificial intelligence, because everyone is talking about AI, but you have to understand that how this AI can be integrated into the geospatial analysis, or how the geospatial data can be integrated in the AI. That is another important art, that how you are managing your DSA or data structures and algorithms so that it can be used in the AI. So you need to understand this one. Okay, so this is the most important thing that you need to understand. Don't try to rush into this type of field directly, because the point from where I am talking this, I have very good expertise in GIS for more than 6 to 7 years, and I have very good expertise in artificial intelligence and coding and understanding the algorithm for more than 3 years. So whatever I'm talking is an experience of more than 6 to 7 years. So you can't jump to it directly, but take a stepping stone. And if you follow this step, you can easily come to this experience of my stage within 3 to 4 years. But you have to also think that you are doing an undergraduate, you have to study hard also. We are now a full-time dedicated researcher, so we are doing experiments and doing research. So that thing will not be possible for you at this particular point. It's not physically feasible now. but you have to try it. You have to make some time out of it. If you are good, if you are interested in learning AIs and programming skills, to give more time to programming apart from your studies. So this will help you to engage your skills actually. So in this way you can work, and you are in the undergraduate, you have a lot of time. Okay, so start exploring, and if you feel any doubt, this the board is here, scanner board is here. You can connect to me in LinkedIn. Yes, any other question? Anyone can ask question also. There is no issue in that. You don't have to type also. Any question from anyone?
If anyone has any question, he or she can ask in the chat.
Okay, Ankon
Okay,
has one
Ankon, you
question.
can unmute yourself and ask, or you
Actually,
can
I can't
write it on the chat
speak
box.
right now, but I can type. Can you please wait, sir, a bit?
Yes, yes, yes.
Okay, okay,
You
not a
can say-
problem. And those who are having problem filling the feedback form, they can try now.
অনেক আমি চ্যাট দেখতে পাবো না না
দেখতে তো পাওয়ার কথা।
আমি আস্কিং, আমি জানি না।
চ্যাট ও এখন লেখিনি।
আমি তো অ্যাডমিন নই না। I am not the hosting, so I don't think I can see the. Sometimes chat is visible, but it is not staying, or I am doing something wrong.
You can check the right side. There is a
I
chat
am
with the
checking.
logo.
Okay, okay, I am watching that also. No, I can't see it, but okay, let it be.
Ankon is asking, is R goes hand in hand along with the AI and machine learning models?
R Studio.
I think so. He is writing
Yes,
R.
R
So
Studio.
this video.
Thing is that if you are new to AI, don't begin with the R. Try to begin with the Python because it gives you much more flexibilities than R. R is there for the basics, and R is good at conventional research. Like sometimes sometimes they provide a good visualizations. Okay, so if you want to really want to work on something that is more than just publishing one paper and working deeply into it, I will tell you definitely take the Python, because whatever changes, whatever updates, everything are making, they are all making in Python. So if you are new to this field, I will tell don't waste time on R, build everything on Python because it is much more reliable, much more optimistic, much more upgraded, and all the new updates comes first in the Python only. R is not that much user friendly also, and the codings in R are much larger than the Python. In Python you can do everything, and the AI assistants are very well equipped with the Python, so there will be no problem with it. You can easily push everything through GitHubs also. So Python is good. I will recommend you Python, and if you know R, then try to expand your knowledge in the R, and try to learn Python, because Python will be mandatory for you. Because I will tell everyone that Python is important because whatever new packages are being made, they're all made in Python. It's not in R. Only research purpose and some of the basic things are in the R. Okay. In machine learning also, you will not get so much of options or package options in the R. Okay, but you can get everything in the Python. Any other questions?
If anyone has more questions, or we will end the session.
Okay.
Don't think others have any questions. So Ankon was
Okay. It's a very good question. GE is a good. See, everyone is talking about GE. Okay. I will tell you that my thought on GE is like that. GE has nothing special in it. If you are making a LULC map, you can make an LULC map on ARC also, ADAS also. You can make LULC map on GE also. In everywhere, you need to give a training data until and unless it is a pre-trained data. So people flexing on GE that I am doing this and that on GE is good. But if you want to be very much optimistic and very much intelligent, smart way of using geospatial analysis, I will tell you learn the GE for downloading the data. For example, you are downloading a star data and you know that your data area is very small. But if you have to download the data from the official SAR website, Copernicus Sentinel-1A website, you have to download more than 20 GB of files. But if you know the GE, then the best thing is that the GE will help you to download the only those area which you will give in the GE as a shape file. For example, as a variable, if you put your shape file in the GE, then GE can easily give you a very good data structure. Okay, so within a very short period of time, you can get a very good data. For example, you want to download the data for a 10 year, 20 years, you just change the name of the change the date, run the code, run the script, and you will get a data. So you don't need to find here and there and don't need to download all the data. You can specify each and everything in the GE. This is the biggest thing that you can do in the GE. Okay. Otherwise, GE is like until and unless Google Earth Engine is integrated with proper machine learning and deep learning algorithms for any susceptibility zonation, I don't think GE has that much of importance till now, because people flex is using GE because Google Earth Engine is by Google and everyone wants to showcase that how they are good with the JavaScript nowadays. But GE is good with the data till at present at where GE is standing. You can downloading data through GE will be the smarter option rather than doing each and every work in GE, because it takes a lot of time, and if there is any one computation wrong, you can't even detect that where the problem is going on actually. Sometimes you download the data, but data get downloaded, but the data is empty. So a lot of problem you can find in GE also. I have worked with GE a lot of time, so I will tell you, that's why I'm telling you. So I don't promote GE that much, but I promote the way people are using GE smartly. I will always promote that, and I'm going to support that.
I don't think any more questions are there. So I would like to thank the organization team and to all the participants who joined the session, special also to our speaker Sayantan. So, but before we close, if you are interested in learning
Sir,
more or collaborating with our
I have
institute,
actually one
SAIARD,
question.
okay,
Sir,
ask.
can you name, like, apart from the famous Python libraries like GeoPandas or like Fiona,
Huh?
like
Can I?
this, like, what are the main Python libraries that are required for your work? Like, apart from the main
See,
GeoPandas, like we know about in
see,
Python library.
thing is that okay, I'm gonna make the things clear. Don't I will tell you, don't be heavily dependent on what type of, or don't get too much concerned with what type of libraries you need, because each and every day now different type of libraries are being created. Most probably what we use is GeoPandas is there. To get an shape file you need Xarray is there. To get a raster file you need Rasterio is there. So you are getting Rasterio, you are getting Xarray, you are getting GeoPandas. Apart from that, you need data attribute table configuration. You need, for that you need NumPy, you need normal pandas also. Then for visualization of these beautiful graphs, you need Matplotlib also, you need Seaborn also. Okay, and for the neural network architecture, you need PyPlot also. So these things are there. So these are the very common things that you will require. But the thing is that, for example, one of the professors has introduced Leaflet. That is a very good Python package for the satellite images. So you can't stick to this few, because each and every day new things are being made. So whatever suits you, whatever is coming today at present will be an optimized version of the whatever they are in the past. So new upgradations are coming, new various softwares are coming. Okay, so don't get stick to that only GeoPandas, NumPy, because that thing is not important. Important is that what will you want to do. If you want to work on something very simple, go and ask the Python and tell me I want to do this thing. Give me a detailed code on this. They will give you a very good number of packages to install that also. But don't stick to that. I have only pandas. I will work on pandas. I have only GeoPandas. I will work on GeoPandas. There are a lot of things that Rasterio can't handle. For example, if a TIFF file is if a TIFF file is converted into a .nc file or netcdf file, you can't handle it with Rasterio also. Okay, and you can't handle it with an GeoPandas also. You have to use some Xarray data files also. So in this way, there are a lot of files. So while you will be working on this type of work, this basically this type of questions will never come to your mind also, that whether I will use GeoPandas or NumPy or raster, because that will never be a problem. You will be having much more bigger problems than this type of packages also. Okay, these are the things.
Okay, thank you, sir.
Okay. Any other question? Okay, someone has raised a hand. Okay, what question it is?
Sir, may I say now?
Yes,
You
yes.
can say.
Yeah. So my question is, if I want to learn the Python and AI, particularly applying on the GIS field, so where should I learn first? What are the
See,
sources can I learn?
the sources you can learn is go to Udemy. You can see there are more than 100 courses on geospatial analysis. First, see on that and how AI has been used. Then you have to do one. You can take the sources from under. First, you try to understand what is this artificial intelligence and deep learning are there in geospatial analysis. There are a lot of books, and nowadays a lot of books. These fields are evolving. You will not get anything directly. When I started the work, I have got nothing. I just started. I just tried and tested, and in this way, I got the idea of how these things are working. So there will be nothing known as spoon feeding, but I will tell you, you have to start from somewhere. No, so go to YouTube. See, there are a lot of Python playlists also. First, learn the Python, very basic Python. Learn the loops. Learn the basic strings and arrays. And after learning the basic thing, you don't have to mug up and memorize. Then learn how to input or extract the data into the Python interface, how to make a visualization. First, learn this type of things using small data and dummy data, and then start learning how geospatial data can be converted for these Python packages. Because to convert your geospatial work into Python, you need to understand what type of geospatial work you are doing and what type of geospatial data you are having, and you have to have a very strong ideas of these data structures and algorithms. Until and unless you are having a good concept on data structures, you can't really work on with this Python also. Okay, so you have to have a very good knowledge of both geospatial analysis as well as the Python, and you can learn these two separately and then try to integrate together. Okay.
Okay.
So Ankon asked a question.
Okay.
Ankon asked a question, how can we get the news of these things coming every day? You can follow our LinkedIn profile. You can get various courses, or if you want to do the internship, okay. And more, if you want to more connect with people associated with in this field, working on this field, you can get in touch with them for better and analysis and better news kind of things. So the link of our LinkedIn channel is provided in the comments. So if you are interested in learning more or collaborating, please feel free to reach out and follow us on our social media handles. Let's continue working together to harness technology for a safer and sustainable future. Thank you once again. I would like to thank Sayantan for once again for giving his so precious time. Stay safe, everyone, and stay connected. Have a great day. Bye bye, everyone.
Thank you.
Thank you. Chandan, then I am leaving. I am calling you on phone.
Yes.
Thank you.
Okay.